Hello class, I hope everyone's doing great when they start watching this video. Today we're going to be learning about Ohm's Law, which helps us relate some of our terms we've learned like voltage, current, and resistance. So, some questions. What are voltage measured in? So I encourage you guys to pause the video, think about it for a second. But voltage is measured in volts. What about current? What is current measured in? Current is measured in amperes. And our what is resistance measured in? Our resistance measured in ohms. So you can see in our picture here that our volt is our potential, our electrical potential. It's what's pushing our current, which is measured in amps, through our wire. So our voltage is like our pressure pushing our current, our flow of electrons through, and our resistance is measured in ohms, is the one restricting, trying to stop us from having our current go through. So the more restriction we have, the more resistance, the more this little cowboy squeezes, the less current we can get to come through it. Some objectives. So by the end of the day, we want to understand the Ohm's Law equation, and then we want to also be able to complete some simple Ohm's Law problems. As always, a good quick video explaining what Ohm's Law is and how it works. But what we're going to look at today is our definition of Ohm's Law. So Ohm's Law is V is equal to I multiplied by R, I times R, where V stands for voltage for volts, I stands for current measured in amps, and R stands resistance measured in ohms. So if we look at our equation, if we say V is constant, let's say our I increases, then our R must decrease. If I is constant and our V increases, then our R must increase. And if R is constant, so we don't change what the value of R is, then if our V increases, our I must also increase. So just some relationships there. We also have this nice Ohm's Law triangle, which shows that if we want to solve for voltage, we do volts is equal to current times R. So volts at the top is equal to the bottom two. If we wanted to solve for current, which is I, we would take V divided by R. We can see V is on top of R here, so it would be V is divided by R. And the same thing with resistance. If we want to find our resistance, we can take our voltage and divide by our current. So let's go through and see examples of using each form of our Ohm's Law. Oh wait, we got a quick simulation here. So this simulation is going to talk about some of these relationships we have, whereas if we have our voltage is constant and our increase our current, then our resistance must decrease. So let's take a quick look at these once we can get this to load. Awesome. So we got our simulation to load. This has 3 batteries in what's called series. So 3 batteries right next to each other. So this is going to be our voltage. This is like having 1.5 volts plus 1.5 plus 1.5 volts. And we can see as if we increase our voltage, so if we go up to 9 volts, we would get 6 batteries. So what changes? So we're going to keep our R the same, our resistance stays the same, and we can see as our voltage gets bigger, our current, this little I right down here, our current is going to increase as well. If we keep R constant, as we make our voltage smaller, as we take away batteries, our I is going to get smaller. As we have our resistance, we can now look at if we keep our voltage the same, what happens to our I, our current. So we're going to keep our voltage the same. As our R increases, our I has to get a lot smaller. We can see our current going down as I increase. So as I go up in resistance, our current goes down. And then the opposite, as I go down in resistance, my current, my I, is going to go up until we get really, really big. So that's just a visual way to see what all of this was saying. All right, so let's, as always, I think it's easiest to learn through examples when we're doing equations like this. So for this example, if we have a circuit, or if a circuit has 12 amps and a resistance of 5 ohms, what is the voltage in the circuit? So step one is always to write what our given is. So we're going to change our we're going to change our numbers into variables. So we're going to say I is equal to 12 amperes. R for resistance is equal to 5 ohms. And now we need to decide which equation do we want to use. Do we want to use this one, our first, second, or third? Well, we're asked for what the voltage is. So we want to make sure V is on the left side of our equation. So we're going to say V is equal to I times R. And then we just get to replace our variables with numbers. We get V is equal to 12 amperes times 5 ohms. And our answer is V is equal to 60 volts. V for volts. So we can say voltage is V, but also volts is V. So we got a couple of V's here. All right. Our next example is if we have a 128 volt. If 128 volts is required to push 4 amps of current through a resistor, what is the resistance? So again, step one is to change our numbers into variables. So our volts is equal to 128 volts. Our current is equal to 4 amps. Our equation is going to be our R equation, this last one, because we're asked what is the resistance. So R is equal to our voltage divided by our current. We get to replace our V for 128 and our I for 4. And if we plug that into a calculator or did it out by hand, we would get our current is equal to 32 ohms. All right, one more example. We have a 40-watt battery maintains current through a 20 ohm resistor. What is the current through the resistor? So again, for step one, to change our numbers into variables, we're going to say 40 volts, V is equal to 40 volts. Our resistance is 20 ohms. And so we're looking for current. So we need I on the left side of the equation. We're going to say I is equal to V divided by R. And then we replace our variables for numbers and divide to get 2 amps. All right, we're going to take if we take notes, this is the ones we're going to write down. So if a circuit has a current of 2.5 amps and a resistance of 2 ohms, what is the voltage? Step one, we're going to change our numbers to variables. So I is going to be equal to 2 amps. R is going to equal 2 ohms. And now we're asked to find the voltage. So we're looking for the equation that has voltage on the left side. So we're going to say V is equal to I times R. We're replacing our variables for numbers. 2.5 times 2 is going to be 5 volts for voltage. Another example, the current is 10 amps and the voltage source is 200 volts. What is the resistance? We're going to do this one together. Again, volts is 200, V for volts is 200, current is I, so I is 10 amps, and we're looking for resistance. So we're going to look for the equation that has R on the left side. R is equal to V divided by I. And if we divide that, we get 20 ohms. All right, so these are, one more example, and then we're going to do some exit tickets. So if a 240 volt source is connected to a wire with 10 ohms of resistance, what is the current? So if we write this one down, or if we change our numbers to variables, we're going to say 240 volts would be V for volt, and ohms is resistance. So R is equal to 10 ohms. The equation is the one that has I in it because we're looking for current. And then we can take 240 volts divided by 10, get 24 amps for our current. All right, so we're going to do 3 exit tickets. I encourage you guys to pause the video and try this on your own. I want you to write it out on a piece of paper and see if you would get the same answer that I would. So please pause this video, try this first one. says if a current has if a circuit has a current of 1 amp and a resistance of 9 ohms, what is the voltage? So step 1, changing numbers to variables. I is equal to 1 amp, R is equal to 9 ohms. Our voltage, we're looking for what our voltage is. So we're going to say V is equal to I times R for our equation. And then we just switch out our variables into our equation. So 1 amp times 9 ohms is equal to 9 volts. All right, we got one more. Again, I encourage you guys to pause the video, please. Try this on your own just to see how well you're understanding this equation in this material. So this question is, if the current is 10 amps and the voltage source is 200 volts, what is the resistance? So again, change numbers to variables. Volts is equal to 200. Our current I is equal to 10 amps. And we are looking for resistance, so we're looking for R. So we're going to say R is equal to V divided by I, which is 200 divided by 10, or 20 ohms. Our last exit ticket, or last one I want you to try, is this one. So again, please pause the video, try to write this out by yourself, and see if you get the same answer I get. Typical wall outlet in the United States provides a voltage of 120 volts to your appliances. What current would be necessary for the electricity to pass through an 8 ohm resistor? So step 1, changing our numbers to variables. We can see voltage V, so V is going to equal 120. You can see our ohm resistor R is going to equal 8, and we're asked what is the current. So our first thing is to change V is equal to 120, R is equal to 8 ohms. We're asked for current, so we're going to use this equation, I equals V divided by R. And then we just replace our variables in our equation for numbers. So we're going to say 120 here. R is going to be 8. And we would get 15 amps. So that's all the example problems and practice I had planned for us on our presentation. I also have a quick little Ohm's Law activity on this live worksheets.com. This is kind of a new thing that I found actually helping some of the other people at the school. One of the other teachers is using this, and so the way this works is all we have to do for this one is it's like a PDF. We get to click in the box and we can fill in our name. So I can say Mr. Max. I can put the date. I can say when I'm recording this, it's 4/28/2020. And I can say my current is measured in, I can say amperes. They just want us to fill in our boxes here using these questions in bold. Our voltage is measured in volts. And let's just write the symbol for voltage. We're going to say V. I'm going to get a couple of these wrong just to show you guys how it works, what we can do, or what happens if we get an answer wrong. And so once I have all my answers finished out, I can hit finish. And I want you guys just to check your answers. I don't want you guys to email it to me. So there should be something that pops up. Let me try again. There should be a grade that pops up and tells me how well I did or how poor I did. So if I hit check my answers, maybe it'll, Well, if this doesn't work, I still want you guys to try this worksheet. If I can't get this to work right now, I apologize. Yeah, all right. I can't quite understand why. Usually it pops up and says you get like a 10 out of 10 or a 5 out of 10. Maybe it'll work for you. If it doesn't work for you, I still want you guys to try and go through this. I think it's a fairly easy worksheet, stuff that we've practiced and seen before. So it's just good practice. So please complete this, even if it does not give you the correct or the incorrect. I just want you guys to try. I hope that makes sense. Sorry if it's a little confusing. If you guys have questions, please let me know.